Hi folks, we're moving on to Chapter 7. Chapter 7 is about quadrilaterals, and but we're going to start out Chapter 7 with working with parallel lines. So some of the work that we're going to do in this the first two sections is something that you've probably done in junior high. I found in past years that a lot of kids have seen this before, but we're going to go over it in a lot of detail here and introduce some theorems. So the first thing here is when you're dealing with parallel lines, if I have parallel lines, or actually if I have just two lines that are drawn, say this line right here and this line right here, and I intersect it with another line, this line, the blue line, is called a transversal. And when I have two lines that are intersected or cut by a transversal, I end up generating a whole bunch of different types of angles. So the first thing here is you have to know that the angles that are in between the two lines that we're talking about, those are interior angles. The ones on the outside of the two red lines, those are called exterior angles. And then when I look at the transversal, if I have angles that are on the same side of the transversal, those are same side angles, and then ones that are on opposite sides or alternate sides of transversal are called, in our book, are called alternate. So if I'm looking at alternate interior angles, so in other words, interior angles that are on opposite sides of the transversal, opposite sides of the blue line, you'd be looking at angles 4 and 6, and you'd be looking at angles 3 and 5. If I'm looking at alternate exterior angles, those would be angles that are on the exterior of the two red lines, and they're on alternate sides of it, so of the transversal. So for example, 2 and 7 would be alternate exterior angles. Also, angles 1 and 8 would be alternate exterior angles. Corresponding angles are angles that when I look at these two intersections, so this intersection and this intersection, if you think about the angles that are on the top left-hand corner at both of those intersections, they would be 1 and 5, and those would be called corresponding angles. Likewise, if I did bottom left, it would be 2 and 6. Top right-hand corner, so it would be 4 and 7, and 3 and 8, of course, would be the bottom right. Same side interior angles are angles that are in between the two red lines, so they're on the interior, and they're on the same side of the transversal, so like 3 and 6, and 4 and 5 would be same side interior angles, and likewise same side exterior angles are going to be angles like 1 and 7 and 2 and 8. Now, to help you remember some of these things, there are some little tricks here. So for example, for alternate exterior angles, the angles are going to form a Z shape. So if I look at an example of alternate exterior angle or interior angles, like 4 here and 6 here, if I trace it out, it's going to make like a Z shape. Likewise, if I had something, if I traced out angles 3 and 5, I'm going to end up with a Z shape also. So here's angle 5 right here, and here's angle 3, and you're going to end up with kind of a Z shape if I turn my page sideways. Corresponding angles are going to form an F shape. So, for example, if I were to trace out the corresponding angles 4 and 7, there's angle 4 and there's angle 7, you can see that sideways, if I flip my paper sideways, it would form an F shape. So corresponding angles are going to end up forming an F shape. Alternate interior angles are going to form a Z shape. Same side interior angles are going to end up forming like a U shape. Like a U, like this. So same side interior angles are going to form a U shape. Okay, so let's try working with some problems here. And so if I look at these angles, it's W, Z, X. So we're looking at this angle right here. And we're looking at ZXY. So ZXY is going to be right here, ZXY. And hopefully you can see that the two lines that we're talking about here are going to be right here and right here. And that would make the thing that's cutting both those lines, the transversal right here. Okay, so in our case here, ZX is the transversal, and of course it forms a Z shape, which means they are alternate interior angles. Alternate interior angles. Okay, let's try another one here. Get my little eraser out. Okay. And VZW, it's right here. Let's use the highlighter. So VZW, and angle Y is down here. Hopefully you can see that that's sort of an upside down F shape. So in this case, here would be the two lines, and here's the transversal that's cutting through the two lines. So my transversal is just going to be VY. And the types of angles here would be the corresponding angles. Now keep in mind that the transversal is always going to be part of both of the angles. So if you're looking for the transversal, that's another way of trying to find the transversal. Okay, and then the next one here is VWZ. So it's this angle right here. And WXY, which is this angle here. Hopefully you can see that's an upside down F shape. And this is the line that intersects the two lines. So it's going to be VX is my transversal. And of course we said that this is going to be corresponding angles. Okay, let's jump down to the next diagram down at the bottom. And it says that ABD, which is this one right here, and CDB, which is this one right here. Hopefully you can see the big Z there. And this angle and this angle are the ones that we're talking about. And they both contain this segment right here, this line right there. So that's going to be my transversal, DB. And we said that's going to be alternate interior angles. Okay, let's jump to the next one. Angle AED. So AED is right here, and BCF is BFC, sorry, it's right here. And so, again, both the angles should contain the same transversal, and the transversal is going to be right down the middle, right here. And the two lines that are going to be intersected would be right here. And so those are going to be alternate exterior angles, and where the transversal is DB. Get a better colored pen here. DB. And that's going to be alternate exterior angles, because it's, if I look at these two lines here, the two angles we're talking about are on the exterior of those two lines. And then the last one here, let's take a look at this. So we're looking at DAE right here, and BCF is right here. Hopefully you can see that there is no line that is in common between that is shared between those two angles. So there is no transversal, and there is really no situation here going on. Okay? So that was a little bit of a trick question. Let's jump to the next page here. Okay, let's start out by identifying some different types of angles here, like we were doing on the front side, just to make sure we're good with that. So here's angle 1, here's angle 2. Hopefully you can see that's an upside down F shape, which we know is our corresponding angles. Angle 3 and angle 4 are right here. You can hopefully see the Z shape, and those are going to be alternate interior angles. Angle 5 and angle 6 again make up a Z shape, which is going to be alternate interior angles. And then here's this shape and this shape. Hopefully you can see that they do kind of have a line in common between them. This center line going like this, that would be your transversal. But they're on opposite sides of these two lines, and it's going to be alternate exterior angles. Alright, so there's some theorems here down at the bottom. And those are the important theorems for these first two sections. So let's introduce these. So the first one is, if you have two lines cut by a transversal so that the alternate interior angles are congruent. So if I have two lines cut by a transversal, let's use a different color pen here. Two lines cut by a transversal, and the alternate interior angles are congruent to each other. If that's true, that means that these lines are parallel to each other. Okay, so the theorem is basically, if your alternate interior angles are congruent, so if the Z-shaped angles are congruent, then you have parallel lines. Same thing with alternate exterior angles. So if I have two lines cut by a transversal, and these angles are congruent to each other, then I know that I have parallel lines here and here. That's the symbol for parallel lines when you have these little arrows. Okay, so alternate exterior angles congruent means you have parallel lines. And then the next one is when you have corresponding angles congruent, or the F shape congruent. So like this angle and this angle forms an F shape. Hopefully you can see that. If the corresponding angles are congruent, then you have parallel lines. Okay, and then if you're looking at, these are a little bit different here. If you look at same side, so same side interior angles are supplementary. So in other words, if this angle and this angle adds up to 180 degrees, same side interior angles, same side interior angles, sup, means you have parallel lines. Likewise, same side exterior angles, so same side exterior angles. If they're supplementary, then you have parallel lines. And then the last one here is basically, if I have two coplanar lines, so it just means that all these lines are on a flat surface, and they're perpendicular to a third line. So if I have a line like this, and I have a line that's perpendicular here, and a line that's perpendicular here, then what I know is that these two lines are parallel to each other. Okay, so if you have two lines that are perpendicular to a third, then you have parallel lines. Now, what you need to know here is that primarily we will be utilizing a lot more of these three right here. Okay, and we'll be doing a lot with those three theorems. A little bit with these two here, and then a lot less really with this one down at the bottom. Now, you also need to know that all the converses of all these theorems work. In other words, these are reversible. So if, for example, this first one here, it says that if alternate interior angles are congruent, then you have parallel lines. Well, you can also say, if I have parallel lines, and now I can do the arrow in the other direction, then the alternate interior angles are congruent. So these are all reversible. I can do this, I can do this, I can do this, I can do this. All those theorems are reversible. If we have parallel lines, then alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, same side interior angles are sup, and same side exterior angles are sup. And so those are the key theorems for this section. So let's flip over to the next page and let's try some problems using those theorems. And tomorrow we'll do some work with proofs with these theorems also. Okay, we're jumping to the side now where we're going to try a few algebraic exercises. So this first problem here is asking, question mark, are these two lines parallel to each other? Now, the thing you can do, I mean, a lot of students right off the bat would say something like, well, then these two would be supplementary to each other. Well, you don't know that yet. You don't know that yet because you don't know that these are parallel to each other. So you got to find some information here that you absolutely for sure know. And in this case, what you do know is that these two, hopefully you can see, are congruent to each other. That's because vertical angles are congruent. So x squared minus 17 equals 5x minus 3. And I can solve this thing. So that means that x squared minus 5x minus 14 is equal to 0. I can factor it. So I get x minus 7 and x plus 2 equals 0. So x is equal to 7 or negative 2. And then I can plug it back in and find the angles here. In particular, I'm going to see that if I plug in a negative 2 here, I'm not going to get positive angle measures. So that's not good. But if I plug in 7 here and here, I'm going to get that this is 32 degrees, and I'm going to get that this is 148 degrees. So that means that they're supplementary to each other, and if the same side interior angles are supplementary, same side interior angles are supplementary, then I know I have parallel lines. So the answer is yes, those are parallel. The next one here, I'm given that these are parallel, so what I can say is I can say that these are congruent to each other because those are corresponding angles. So now I can go ahead and say that x squared plus 20x is equal to 4x plus 36. Solve this thing, set it equal to 0, x squared plus 16x, sorry. Subtract 4x from both sides. Minus 36 equals 0. Factor it, I get x plus 18, x minus 2 equals 0, 0 product property it, so x is equal to negative 18, positive 2. And I can plug in both of those. Hopefully you can see that the negative 18 is not going to work because I'm going to get a negative angle right there. So I'm going to plug in 2 in for this angle right there. Hopefully you can see that that's going to be 44. And if that angle is 44, then this one's going to be 136 degrees. Okay, looking down at the bottom here, these are what's called Crook Problems. And what you might want to do right now is pause the video and go ahead and try this first one, just for fun. Normally in class, that's what we would do. We would pause and let you give this a shot. So hopefully you've had a chance to pause it and try it, but the best way to approach these, I mean, there's a couple of ways you can do these, but the best way to approach these is to do this. I have these two parallel lines here and here. Well, I'm going to draw in through this point of, I'm going to call it a point of inflection, where it changes directions. I'm going to draw in a parallel line that is parallel to the other two parallel lines and goes through that point where it changes directions, that point of inflection. And what I've done now is I've created a whole bunch of parallel lines. So for example, I now have a bunch of relationships based off of the parallel lines. So for example, this angle right here is congruent to this angle. So I know that this one's 40. I also know that this angle is same side interior angles with this 100 degrees. So that means this has to be 80. So that means that the entire angle 1 is going to be just equal to 80 plus 40, or 120 degrees. Okay, and likewise, I'm going to try this problem down at the bottom. You can always pause the video here and give it a shot, but I'm going to go ahead and I'm going to draw in a bunch of parallel lines to the top parallel line and the bottom parallel line. And I'm going to create all these relationships. So I know that if this angle right here is a right angle, I know this has to be a right angle right there. I also know that if this is a right angle, then this remaining piece has to be 30 because it was together 120 degrees. And then hopefully you can see that there's a Z shape here. There's an alternate interior angle right here. Okay, so that means this one's also 30. And then hopefully you can see that because this whole thing is 80, this one must be 50. And then again, I have another alternate interior angle there. And so this has to be the same as that 50, or 50 degrees. And I'm done. So these problems, generally speaking, are not difficult as long as you know the little trick of drawing in the parallel lines. And then it actually becomes very easy. Okay, I'll let you go ahead and give the problems a try now. Okay, take care.